Alright, in section 8.1 we're going to be solving systems of equations, and a system just means that we're going to have more than one equation to solve at a time. These notes are optional. You do not have to copy these down. I will not put them on Monday's notebook quiz, but I would like for you just to listen through the examples. So the first set of directions say determine if the given ordered pair is a solution of the system. So they're going to give you an ordered pair. We know ordered pairs are x values and y values. So to check to see if this ordered pair is a solution to the system, it means that the ordered pair has to be a solution to each equation. So into each equation, you'll put a -3 in for each x and a 5 in for each y. And you're going to check to see if the left-hand side is equal to the right-hand side. So that gives me -27 plus 35, which does give me 8. So that means the point checks in the first equation, and then I'm going to try the ordered pair or the point in the second equation. So 8 times -3 minus 9 times +5. We're checking to see if that equals -69. So that's going to be -24 minus 45, which does equal -69. So if the ordered pair is a solution to both equations, then it is a solution to the system, and you're just going to write yes if it is. Example 8 is asking you, the directions are changing here, and they're asking you to solve the system. So this time they're not going to give you the ordered pair, which represents your solution. You're going to have to find that. So the substitution method means we're going to take one equation and solve either for x or y. And since the second equation is already solved for y, then we're going to take this second equation and we're going to take the 2x plus 7 because that's what y is equal to. We're actually going to substitute in 2x plus 7 into the y in the first equation. So you'll take one of the equations, solve for a specific variable if it's not already solved for a variable, plug that value into the other equation. So since the second equation is solved for y, we're going to take 2x plus 7 and substitute that into the y in the first equation. So that's going to give us 2x minus 3, and in the place of y, we're going to substitute in 2x plus 7. And then we're going to finish out that equation and set it equal to -13. And the reason that this is helpful is because once I substitute in the 2x plus 7, then that gives me a nice little equation with just one variable. Anytime you can get down to one variable, that's just going to make your system easier to solve. We're going to combine like terms, and then we'll solve for x. So we're going to add 21, divide by -4, and x is going to be equal to -2. Now to find your solution, you have to have an x and a y. So we know what our x is. So what I'll do next is I will take my x equals -2, and you could plug it into either one of the original equations, but I'm going to plug it into y equals 2x plus 7 just because it's going to be easier to plug in there. So if x is -2, then y is going to come out to be...
Miss Prater?
And -4 plus 7 is 3. So y is 3. So they're going to write this solution as an ordered pair. So we found out that our x from our solution was -2 and our y was 3. So they'll write the solution as an ordered pair. Alright, number 12, same directions are asking us to use the substitution method. So since neither equation is solved for x or y, you're going to want to pick an equation and solve for one of the variables. So I'm going to pick the second equation, and I'm going to solve it for y. So the easiest way that I can see to do that is to add y to both sides or move the -y over. So now since the second equation is solved for y, I'm going to take what y is equal to, and I'm going to plug that into the y in the first equation. So that's called the substitution method. So 4 times... Oops, let's go back and redo that. The 2x is going to go into the y, not the x. So we're going to have 4x plus 3 times y, which is 2x is equal to 0. this helps us out because we now have an equation that just has x's in it. And we'll solve for x, and x is going to come out to be 0. And then we're going to plug our x back in. You can plug it back into either one of the original equations, but it's be pretty easy to plug it in here. So 0, 0 is a solution to both equations. So it's called the solution of the system. All right, going to change directions. This set of directions say solve each system by the addition method. You may also know this as the elimination method. That's what your Algebra 1 teacher probably called it. So what you want to do here is you don't want to solve for x or y. That's the substitution method. You want to try to get your x's to cancel or your y's to cancel. We can do that by multiplying through either equation or sometimes both equations by a number. So what you're going to do is you're going to look at your x's. So we have a positive 3x and a positive 6x. So if we added 3x and 6x, we would get 9x. So what the goal is to be able to add 3x and 6x, and those terms cancel. So if we could turn the 3x into a negative 6x, then the negative 6x and the positive 6x, when we add those together, would cancel out. That's really why the elimination method is probably a better name. So you can make that happen. You can make the x's cancel. You can make the y's cancel. You can use or eliminate there by multiplying by any number that you want. You can choose. So you'll be looking or thinking about a number that you can multiply through either one equation or both equations to either get the x's or the y's to cancel. So I'm going to cancel the x's by multiplying the top equation by negative 2. And I chose negative 2 because negative 2 times positive 3x is going to give me that negative 6x. And the negative 6x is going to cancel with the positive 6x. Negative 2 times negative 7y is positive 14y. Negative 2 times positive 13 is negative 26. And then what you're going to do is you're going to add these equations. So you're going to add the original second equation with the first equation that's been multiplied by negative 2. And when you add those up, positive 6x and negative 6x cancel. And you get 19y, because 5y and 14y add up to be 19y, and positive 7 and negative 26 add up to be negative 19. And then once one of the variables goes away, you have an equation that just has one variable. So that's what you're trying to get to, an equation that just has one variable. You'll divide both sides by positive 19, and y comes out to be negative 1. You'll take your negative 1 and you'll plug that back into either one of your original equations. I'm going to plug it back into the second equation only because I don't have any negatives, and sometimes negatives cause us to make mistakes. So we'll do 6x plus 5 times negative 1 is equal to 7. Now my equation only has x's in it, and so I will solve for x, and x comes out to be 2. And then I write the solution to my system as 2, negative 1. And remember, like the first set of directions, if you want to check to make sure that you have the correct answer, then your x and your y would go back into both equations, and the 2 and the negative 1 would be a solution to both of the original equations. So these are always fairly easy to check. The directions are going to change here, and they're just going to say, hey, you can choose your method here. So that means you can use substitution or you can use addition. It also tells us to identify systems with no solutions, if that's the situation, and also identify systems with infinitely many solutions, using set notation to express their solution. So if we get to pick here, substitution would be the better method because one equation is already solved for y. So I'm going to take this 3x minus 4 and I'm going to put it into the y in the first equation. So that's going to give me 9x minus 3 times 3x minus 4 is equal to 12. That gives me an equation that only has x's, which is a good thing. And so just want to kind of show you how you would pick substitution here. That would be the better pick, but you can pick addition if you want to. You would have to move that y equals 3x minus 4. You'd have to move that 3x over to the left-hand side and get the x's and the y's to line up. So our 9x's are going to cancel, and something different is going to happen here. we're going to get two numbers that are equal to each other, and our variable is going to go away. So we're not going to be able to solve for x. Okay? So, so what that means is if your x's cancel, then your answer is either going to be no solution or infinitely many solutions. So if your variables cancel and you're left with something that is true, so you're going to ask yourself, is 12 equal to 12 true? All right, it is true, 12 is equal to 12. So this is not no solution. So what's happening here is we really have two equations that are the same. They're the exact same equation. So if you took this first equation, and you're not going to do this, I'm just explaining what we're doing. If you took this first equation and you solved it for y, you would get negative 3y equals negative x plus 12. Then you would divide everything by negative 3. And you would get y is equal to positive 3x minus 4. So what we really have is we have two equations that look different, but once you get them in the same form, you realize that they're the same exact equations. So I just kind of want to explain to you what we have here. So it's like we have two lines that are exactly the same. We have one line that's actually on top of each other, of the other one. So what's happening here is that these lines are intersecting at so many points, we can't say they intersect at one exact point. They intersect at so many points, we have to say that there are infinitely many solutions. So in our previous problems where we said the solution is 2 comma negative 1, it meant that those two linear equations intersected at that specific point. So when you find a solution to a system, graphically, it's the point of intersection. So in this situation, since the x is canceled and I was left with something that was true, what that meant is that the two equations were the same and that they would intersect at infinitely many solutions. Same set of directions here. In this problem, I would not choose substitution. I would choose the addition method. And we've got to figure out how we can get the x's to cancel and the y's to cancel. So what I would probably do first is I would probably get rid of the 6, the 2, and the 3. So you would think of a number that 6 and 2 and 3 would go into. If you couldn't think of that number, then you can multiply all those together. But 6 would be the smallest number that you could multiply by. And if I multiplied 6 times x over 6, that would give me a positive x. But I actually want that x to be negative, so it will cancel with the positive x in the second equation. So I'm going to multiply by negative 6. And sometimes to get the x's or the y's to cancel, you have to pick a number to multiply. You have to multiply a number times both equations. May not be the same number, but sometimes you have to multiply numbers into both equations. So negative 6 times positive x over 6 is negative x. Negative 6 times negative y over 3 is positive 3y. And negative 6 times 1/3 is negative 2. Now we're going to add these equations. The x's cancel. I get positive 5y is equal to negative 5, and so y is equal to negative 1. Pick any original equation. I'm going to pick the second one. And x comes out to be negative 1 when y is negative 1. So that would be your solution. Now I'm going to go back to the previous problem because I want to talk about no solution. So in number 34, it's infinitely many solutions because you were left with 12 equals 12, which is true. So if your variables canceled out and you were left with something like 10 is equal to 12 or 0 is equal to 12 or two numbers that were not equal, that would be a false statement, and that's when you actually get no solution. And your no solution is just a situation where your lines are parallel and they're never going to intersect. So there are no points of intersections there. All right, number 44, last one. Let x represent one number and let y represent the other number. Use the given conditions to write a system of equations, solve the system, and find the numbers. So you'll be given a word problem. You will have to use x and y. or two variables of your choice, and you'll have to write a system and solve it. So the first sentence of the problem says the sum of two numbers is 2. So that means x plus y equals 2. The second sentence says one number is subtracted from the other number. If one number is subtracted from the other number, their difference is 8. So that would be x minus y is 8. So you would write your own system based on the information in the word problem, and then you would decide whether you wanted to use the substitution method or the addition method. This system is actually set up for the addition method because the x's and the y's are all on the same side. And we're actually lucky enough that the positive y and the negative y already cancel out. So we're just going to add these up. X plus x is 2x. Positive y and negative y cancel. 2 plus 8 is 10. Solve for x. X comes out to be 5. Pick either one of the original equations and substitute in your x and solve for y. So your solution or your point of intersection, all the same thing, is the ordered pair 5, negative 3. All right. Hope this helps you with your homework. Again, you do not have to copy these notes down if you did. Sorry you didn't listen to the beginning of the video, or maybe you wanted to copy them down. Good luck. Thanks.